Good day, ladies and gentlemen. This is the 17th lecture of the second series of lectures related to the implementation of the RM software for filtering. In this lecture, we will talk about synthesis of transfer function of bandpass filters, which simultaneously approximate the amplitude and group delay. The group delay will be approximated in maximally flat sense, and three versions may be obtained. The first one is maximally flat but horizontal or constant group delay approximation, and the rest are skewed, which means the group delay may approximate a straight line with positive or negative slope. The amplitude characteristic on its own will be allowed to have transmission zeros on the frequency axis, which will boost the selectivity. The content is, as usual, we will first name the project and we will introduce the design requirements. Then we will go for the synthesis of the transfer function and analysis of the obtained results, and then we will go to system realization, which in this case is limited to active RC, active SC, and digital infinite impulse response realization, meaning that there is the RM software is not offering LC realization of this kind of filters. So we will start as usual by activating the main program and by allowing the blocked content. And before proceeding to the design, we will visit the recommended design sequences slide. Here we will make the plan, which is to enter the project name, then to go to the bandpass design requirements introduction, and then to visit the BPTDAM software or program, which will create the transfer function. Synthesis of the system will be allowed. As you can see, there is no passive LC realization available. In the meantime, we may analyze the obtained results by the program TF analysis or by directly reading the CSV file created by the BPTDAM software. So let's design. First, we will give the project name, which will be BP Simultaneous. Then we will proceed with the design requirements: 100 kHz central frequency, 110 kHz upper limit of the passband, 160 lower limit of the upper stopband, 90 kHz lower limit of the passband, 40 kHz upper limit of the lower stopband, minimum stopband attenuation 3 dB, maximum stopband attenuation 3B, and minimum stopband attenuation is 40. Group delay slope, we may give any number, positive, negative, or 0, but we will go for the 0 now in this example. One can find other examples in the documentation of the program within the so-called tutorials. 0, normalized resistance 1 kilo ohm, which has no importance in this case. Now we may proceed with the simultaneous bandpass approximation, and we will have to define the filter here, which will be 14th order with 8 zeros at the frequency axis, both positive and negative, and with 2 zeros at the origin. One should have in mind that the negative image of the amplitude characteristics is more influencing the lower part of the positive frequency response, so that by putting 2 zeros in the origin and leaving 4 zeros at infinity, we are trying to make some balance to reach symmetry. Now we may run the program, and since it takes time, we will now stop the recording. So the approximation procedure finished, we may proceed now to the system synthesis. And we will go first for the RC cascade. Done. Let's see. What we got. This is the SPICE. RCC means RC cascade. And we will open it with SPICE. And here we have to do 2 corrections. So it is linearly, arithmetically symmetric, not geometrically symmetric, and group delay. And you can see here the constant group delay all over the passband. Now we will proceed with the RC parallel and look for the new SPICE RCP. And again, we are getting perfect response, constant group delay, and arithmetically symmetric amplitude characteristic. Now we will go for the digital first. 10 megahertz sampling. And we will look for the CSV file. This is the response of the digital filter approximating simultaneously amplitude and phase. Let's see the diagram. So as you can see, it's perfect. This is the phase. This is the attenuation. This is the amplitude characteristic, and this is the group delay. And now we will go for the SC, which, as already mentioned, has to be weighted for time domain analysis. It is done now. And here is the SPICE file. Somewhere here. Let's see. SC, of course. SC parallel. And here it is running now, and so you can see it's quite a complicated circuit because of the so many switches, and this is the output of the second anti-aliasing cell, and it is running slowly. So that would be the story of synthesis of simultaneously transfer functions simultaneously approximating amplitude and group delay.